Hello friends, in this AV we are going to take up the numericals of chapter 7, that is sound, of ICSE class 10 physics. We are taking up the numericals from exercise 7a. Here the first numerical says the wavelength of waves produced on the surface of water is 20 centimeter. If the wave velocity is 24 meter per second, we have to calculate the number of waves produced in 1 second, and then which is the frequency, and then we have to calculate the time in which one wave is produced. Now here, before we take up this question, first of all we'll need to convert this 20 centimeter into meter, and let's take a look at the formulas that we are going to use for this exercise. So this is the list of formulas that we are going to be requiring to solve this numericals given in these exercises. The first one is velocity is equal to frequency multiplied by wavelength. This you are doing it in this chapter, but if you remember, you have done it in class 9 as well. Then frequency is equal to 1 by time period, or time period is equal to 1 by frequency. They are the reciprocals of each other. This also you have done it in the first chapter of class 9 when you were doing the topic simple pendulum. And then the time required to hear the echo, t, will be equal to total distance divided by speed of the sound. So distance is denoted as d. Why 2? Because first of all the sound will be sent, and after reflection it will come back, so it's covering twice the distance. That is why 2d divided by the velocity. So from here the distance can be taken out by modifying the formula as d is equal to velocity multiplied by time divided by 2. So here we have been asked to calculate the frequency and then the time. So here we have written the given things. Wavelength is 20 centimeter. We convert it to meter, that is we divide it by 100. Then wave velocity is given as 24 meter per second. So for frequency, we know that frequency is equal to velocity divided by wavelength. That is the very first formula which we were talking about. We just modified it in terms of frequency. So velocity is given to us, that is 24, divided by wavelength has been provided to us, that is 20 into 10 raised to the power minus 2 meters. So this we are writing it as 100, 24 into 100 divided by 20. Simple calculation. We get the answer as 120 Hertz. Now for the second part, time is equal to the reciprocal of frequency. We have calculated the frequency. We simply put the value 1 by 120, that is 0.0083. So this we are writing it as 8.3 multiplied by 10 raised to the power minus 3 seconds. Now let's take a look at the second question. It says that calculate the minimum distance in air required between the source of sound and the obstacle to hear an echo. Take speed of sound in air equal to 350 meter per second. Now here the time after which the echo can be heard is 0.1 second. If you read the first part of this chapter thoroughly, you will come across it that the minimum time required to hear the echo is 0.1 second. So we are going to use that here. So you see distance is equal to Vt by 2, that is velocity multiplied by time divided by 2. We have already discussed this formula in the beginning of this AV, so I'm just using it directly. Velocity is 350 multiplied by the minimum time after which we can hear the echo. It's not given in the question, but we have read it. So that is 0.1 seconds divided by 2. So after calculating, it comes out to be 17.5 meter. Now the third question says, what should be the minimum distance between the source and the reflector in water so that the echo is heard distinctly? Now here the speed of the sound in water is not 350 but 1400 meter per second. Again, same thing as we did question number 2. So you may see here velocity is 2d upon t, or d is equal to velocity into time divided by 2. So we simply put the value velocity that is the speed of sound in water is 1400 multiplied by the time taken for the echo to be heard is 0.1 second divided by 2. So you calculate it and you get it, the answer. Next is question number 4. It says a man standing 25 meters away from a wall produces a sound and receives the reflected sound. The distance is 25 meters. We have to calculate the time after which he receives the reflected sound, that is the echo, if the speed of the sound in air is 350 meters per second. And will the man be able to hear a distinct echo? Explain the answer. The second part, obviously he is going to hear the echo, and since the echo can be heard after 0.1 second, till that time the actual sound exists. So probably the time that we are going to calculate, it is going to be more than 1.1. So the second part, the answer is already given. We'll just concentrate on the first part. So here V is equal to 2D upon T. This formula we know. We modify it in terms of time. So time is equal to twice the distance divided by velocity. So 2 multiplied by the distance is 25 meter divided by the speed of sound in air is 350. So 25 into 250 divided by 350, when you calculate it, it comes out to be 0.143 second. So automatically the second part, the answer becomes yes. And they have already given the reason, so I'm not going into it. Let's take a look at the next question, question number 5. It says that a radar sends a signal to an aeroplane at a distance 300 kilometers away. This is the distance, with a speed of 3 into 10 raised to the power 8 meters per second. After how much time is the signal received back after reflecting from the aeroplane? We have to calculate the time. Now here we have written the given things. Distance is 300 kilometers. I convert it into meters by multiplying it by 1000. Speed is 3 into 10 raised to the power 8 meters per second. Now we know that time is equal to 2D divided by V, that is twice the distance divided by the speed or the velocity. So we have the values given to us. 2 multiplied by 300 into 1000, that is we change the distance into meter, and then divided by the velocity, that is 3 into 10 raised to the power 8. So 300 into 2, 3 into 2 is 6, and then all the zeros I write it as 10 raised to the power 5. Now here you see, if you divide 6 by 3 you get 2, and here we will apply the law of exponents. So 5 minus 8 will be 10 raised to the power minus 3 seconds. Now we go to the next question, that is question number 6. Question number 6 says a man standing 48 meters away from a wall fires a gun. So the distance between man and the wall is 48 meters. We have to calculate the time after which an echo is heard, and they have given us the speed of sound in air, that is 320 meters per second. Now for this we have written the given things, that is distance is 48 meters, speed of sound is 320 meters per second. So we know that time after which an echo can be heard is time or time period T is equal to 2D upon V. So here 2 distance is 48 and then divided by the velocity of sound in air, that is 320. So after calculation we get it to be 0.30 seconds. Now let's take a look at the next question, that is question number 7. It says a ship on the surface of water sends a signal and receives it back from a submarine inside the water after 4 seconds. So this is the time given to us. We have to calculate the distance of the submarine from the ship when the speed of sound in water is 1450 meters per second. So here time is given to us, that is 4 seconds. Speed of sound is 1450 meters per second in water. So we know that distance is equal to velocity multiplied by time divided by 2. We simply put the values, that is velocity is 1450 multiplied by time, that is 4 seconds, divided by 2. It comes out to be 2900 meters. So we convert it into kilometers by dividing it by 1000 and we get 2.9 kilometers. Now let's take a look at the next question, that is question number 8. It says A pendulum has a frequency of 5 vibrations per second. An observer starts the pendulum and fires a gun simultaneously. He hears the echo from the cliff after 8 vibrations of the pendulum. If the velocity of the sound in air is 340 meters per second, find the distance between the cliff and the observer. Now to find the distance, we need the velocity, that is the speed which has been given to us, and we need to have the time. Now that time can be calculated using the pendulum thing. So here they have said that it has a frequency of 5 vibrations in 1 second. So for 8 vibration, what is the time it takes? That will be 8 by 5. So that will give us the time which it takes for the observer to hear back the sound, and that time we are going to use in the formula for distance. So here 5 vibrations in 1 second, which means 8 vibrations will be in 8 by 5 seconds. So when you divide, you get it as 1.6 second. Now we know that distance is equal to velocity multiplied by time divided by 2. So velocity has been provided to us, that is 340 multiplied by time we have calculated using the pendulum thing. So we get it as 1.6 divided by 2. So this is a simple calculation which gives us the answer 272 meters. Now we check the next question, that is question number 9. It says a person standing between the 2 vertical cliffs produces a sound. 2 successive echoes are heard at 4 seconds and 6 seconds. We have to calculate the distance between the cliff, and the speed of the sound in air is 320 meters per second. They have given us the hint that the first echo will be heard from the nearest cliff and the second echo will be from the further cliff. That is obvious. So here we have written that the first echo which he hears, the time taken to hear the first echo is 4 seconds, and the time taken to hear the second echo is 6 seconds. Now the distance of the first cliff from the person is 2d1 equal to velocity into time. Please do not get confused. d1 we are just writing to show that this is the first distance, and this is the same formula, d is equal to vt by 2, just that 2 I have written here. So the first distance, that is d1, is equal to velocity into time divided by 2. Velocity is 320 multiplied by the time, that is 4 seconds, divided by 2. So you can cancel 4 with 2, you get 2 here. 320 into 2, 640 meters. Now the distance of the second cliff from the person, we are denoting it as d2. Again it is vt by 2. So velocity remains the same, that is 320 multiplied by the time has changed, that is 6 seconds. It's given in the question. So 320 into 6 divided by 2. Again, if you cancel 6 from 2, you get a 3 here. 320 into 3 is 960 meters. Now the total distance between the cliff will be d1 plus d2. So here we have d1 plus d2. d1 is 640 plus d2 is 960. So total comes out to be 1600 meters. That is the answer. Now we check question number 10. Please note that this is an important question. Now it says a person standing at a distance x in front of a cliff fires a gun. Another person B standing behind person A at a distance y from the cliff hears the sound of a fired shot after 2 seconds and 3 seconds respectively. We have to calculate x and y, and the speed of sound is 320 meter per second. So here this is the scenario. This is the cliff and person A is standing at a distance x. A person B is standing behind A, which is at a distance y from the cliff. So this distance between A and B will be y minus x. Please remember this. And then we have the solution for question number 10. Now first sound that the person will hear is from the gun, and the second sound which he hears comes after the reflection from the cliff. So for the speed of sound remains the same in both the cases, that is 320 meter per second. So time taken to reach from A to B directly, that is the first sound is from the gun. So for first sound, speed is equal to distance and speed is equal to distance divided by time. So speed is 320 meter, time is 2 seconds. Distance, for the first part, please see, the person is able to hear the sound directly from A to B. So this distance, I had told you, the total distance minus this part, that is y minus x. Y minus x. So this is our distance. That is why it says here 320 is equal to y minus x divided by 2. Solve it. This is a simple equation. Now we mark it as equation 1. Then after reflection, he hears the second sound. Now that is again using the same formula, 320 is equal to, now the second sound comes after the reflection. So after the reflection, the sound has to cover the distance x and y. If you have a confusion, you may have a look. It's being fired from here, from A, so it takes this distance, that is x, and then after reflection it reaches B, that is y. So the total distance is x plus y or y plus x divided by the time taken is 3 seconds. Now again 3 is multiplied this side, y plus x is equal to 960. That is equation 2. Now when you add equation 1 and 2, this is what you are going to get. X and x will cancel out. You have 2y, and 640 plus 960 is 1600. So y will be 1600 divided by 2, that is 800 meters. If y is 800 meters, you can just put the value of y in either equation 1 or equation 2. So the value of x will be 960. I have substituted the value of y in equation 2. So x will be equal to 960 minus y. So 960 minus 800, that is 160 meters. And so the value of x is 160 meters, the value of y is 800 meters. In exam, you may just put this answer in a box just to make it look beautiful. Now we go to the next question, that is question number 11. It says, on sending an ultrasonic wave from a ship towards the bottom of a sea, the time interval between sending the wave and receiving it back is found to be 1.5 seconds. So time is 1.5 seconds. If the velocity of the wave in sea water is 1400 meter per second, we have to find the depth of the sea, that is the distance. Now here velocity is 1400 meter per second, time is 1.5 seconds. So we know that the depth of the sea, which is nothing but the distance, is equal to velocity multiplied by time divided by 2. So 1400 multiplied by 1.5 divided by 2. Again, if you cancel 1400 with 2, you get 700 multiplied with 1.5. It comes out to be 1050 meters, which is the answer. Now the last question, that is question number 12. Figure shows the displacement, distance and displacement graph of two waves. Now we have to compare the amplitude and the wavelength of the two waves. Now if you remember, in class 9 you have come across these words, what is amplitude, what is wavelength. So this distance, the highest peak, that is the crest, this distance is known as the amplitude. So for the first wave, which is being shown to you in blue color, the amplitude is 10, and for the second wave, the amplitude, that is the highest point of the crest, is 5. So 10 is to 5 is nothing but 2 is to 1. This is the answer. And the second part is we have to compare the wavelength. So wavelength is this distance, this whole distance from 0 to 4. That means the first one is 4, and this will be half and this will be full. So wavelength is from 0 to 8 for the blue wave, and for the black wave it is 0 to 16. So here when we compare the wavelength of the two, we have 8 divided by 16, or 8 is to 16, which is nothing but 1 is to 2. That is the answer. This question can be done orally, so I have not written anything. I hope this AV was useful to you. Thank you so much. God bless you all. Happy learning. Do well.